Hello, good morning, good afternoon, good evening, everyone. Thank you for welcome back to my shadowing practice today. I'm focusing on improving my fluency and pronunciation. Let's dive into today's shadowing. And today's content is how ChatGPT works technically, ChatGPT architecture. It's made by no, Bright Byte Go, sorry. Uh, yes, of course, every day I use ChatGPT to ask English questions and only have a chat and something like that. So let's listen.
In this video, we take a look at how ChatGPT works. We learned a lot from making this video. We hope you will learn something too. Let's dive right in. ChatGPT was released on November 30th, 2022. It reached 100 million monthly active users in just 2 months. It took Instagram 2.5 years to reach the same milestone. This is the fastest growing app in history. Now, how does ChatGPT work? The heart of ChatGPT is an LLM, or a large language model. The default LLM for ChatGPT is GPT 3.5. ChatGPT could also use the latest GPT-4 model, but there is not much technical details on GPT-4 yet for us to talk about.
By 2 years ago.
Now, what is large language model? Now, a large language model is a type of neural network-based model that is trained on massive amounts of text data to understand and generate human languages. Now, the model uses the training data to learn the statistical patterns and relationships between words in the language, and then utilizes this knowledge to predict the subsequent words, one word at a time. Now, an LLM is often characterized by its size and the number of parameters it contains. The largest model of GPT 3.5 has 175 billion parameters spread across 96 layers in a neural network, making it one of the largest deep learning models ever created. The input and output to the model are organized by token. Now, tokens are numerical representations of words, or more accurately, parts of the words. Numbers are used for tokens.
You can separate each term, each word, and replace it to token.
Rather than words, because they can be processed more efficiently. Now, GPT 3.5 was trained on a large chunk of internet data. The source data contains 500 billion tokens.
My favorite color is red. I love pizza. 2 plus 2 is equal.
Looking at it another way, the model was trained on hundreds of billions of words. Now, the model was trained to predict the next token given a sequence of input tokens. It is able to generate text that is structured in a way that is grammatically correct and semantically similar to the internet data it was trained on. Now, but without proper guidance, the model can also generate outputs that are untruthful, toxic, or reflect harmful sentiments. Even with that severe downside, the model itself is already useful, but only in a very structured way. It can be taught to perform natural language tasks using carefully engineered text instructions, or prompts. This is where the new field prompt engineering came from. But to make the model safer and to be capable of question and answer in the style of a chatbot, the model is further fine-tuned to become a version that was used in ChatGPT. Fine-tuning is a process that turns the model that does not quite align with human values into a fine-tuned model that ChatGPT could use. This process is called reinforcement
Training
training from
GPT.
human feedback, or RLHF. OpenAI explains how they ran RLHF on the model, but it's not easy to understand for non-ML people. Let's try to understand it with an analogy. Imagine GPT 3.5 as a highly skilled chef who can prepare a wide variety of dishes. Now, fine-tuning GPT 3.5 with RLHF is like refining this chef's skills to make dishes more delicious. Initially, the
Yes.
chef is
Right.
trained with a large set of recipes and cooking techniques. However, sometimes the chef doesn't know which dish to make for a specific customer request. To help with this, we collect feedback from real people to create a new dataset. The first step is to create a comparison dataset. We ask the chef to prepare multiple dishes for a given request, and then have people rank the dishes based on taste and presentation. This helps the chef understand which dishes are preferred by the customers. The next step is reward modeling. The chef uses this feedback to create a reward model, which is like a guide for understanding customer preferences. The higher the reward, the better the dish. Next, we train the model with PPO, or proximal policy optimization. In this analogy, the chef practices making dishes while following the reward model. They use a technique called proximal policy optimization to improve their skills. This is like the chef comparing their current dish with a slightly different version and learning which one is better according to the reward model. Now, this process is repeated several times, with the chef refining their skills based on updated customer feedback. With each iteration, the chef becomes better at preparing dishes that satisfy customer preferences. To look at it another way, GPT 3.5 is fine-tuned with RLHF by gathering feedback from people, creating a reward model based on their preferences, and then iteratively improving the model's performance using PPO. This allows GPT 3.5 to generate better responses tailored to specific user requests. Now we understand how the model is trained and fine-tuned. Let's take a look at how the model is used in ChatGPT to answer a prompt. Conceptually, it is as simple as feeding the prompt into the ChatGPT model and returning the output. In reality, it is a bit more complicated. First, ChatGPT knows the context of the chat conversation. This is done by ChatGPT UI feeding the model the entire past conversation every time a new prompt is entered. This is called conversational prompt injection. This is what ChatGPT appears to be context-aware. Second, ChatGPT includes primary prompt engineering. These are pieces of instructions injected before and after the user's prompt to guide the model for conversational tone. These prompts are invisible to the user. Third, the prompt is passed to the moderation API to warn or block certain types of unsafe content. The generated result is also likely to be passed to the moderation API before returning to the user.
Response generation return.
And that wraps up our journey into the fascinating world of ChatGPT. There was a lot of engineering that went into creating the models used by ChatGPT. The technology behind it is constantly evolving, opening doors to new possibilities and reshaping the way we communicate. Now tighten the seat belt and enjoy the ride. If you like our videos, you might like our system design newsletter as well. It covers topics and trends in large scale.
Okay, so today I try to shadow 2 minutes. If possible, I'd like to shadow 2 minutes or 2 minutes 30 seconds. So,
Now, the model was trained on 100 billion chunk of internet data. GPT 3.5 was trained on a large chunk of internet data. The source rather than words because they can be processed more efficiently.
Efficiently. Okay, here. 2 minutes. 3 seconds mark. Okay, let's dive in.
In this video, we take a look at how ChatGPT
How
works.
ChatGPT
We
works.
learned
We
a
learned
lot from
a lot
making
of
this
making
video.
this
We
video.
hope you will
We
learn
hope you
something
learn
too.
something too. Hmm. In this video, we take a look at how ChatGPT works. We learned a lot from making this video. We learned a lot from making this video. We hope you will learn something too. Next,
Let's dive right in.
Let's dive right in.
ChatGPT
ChatGPT
was
was
released on
released on
November
November
30th,
30th,
2022.
2022.
It reached
Reached
100 million
100
monthly
million
active
monthly active
users
users
in just 2
just
months.
months.
It took
It took
Instagram two and a
Instagram
half
2.5
years to
years
reach the
to
same
reach the same
milestone.
milestone.
This is
It took Instagram 2.5 years to reach the same milestone. Oh, in the case of Instagram, it took 2.5 year to reach the same milestone. Only ChatGPT reached 100 million only just 2 months. Wow, it's very, very, really quickly. ChatGPT months to reach 100 million global monthly active users. Next.
is the fastest growing app in
Growing
history.
up in history. This is the fastest growing up in history.
To reach the same milestone.
Same
This
milestone.
is the fastest growing app in history.
Fastest growing up in history.
Now, how does ChatGPT work? The heart of ChatGPT is an LLM, or a large language model. The default LLM for ChatGPT is GPT 3.5. ChatGPT could also use the latest GPT-4 model, but there is not much technical details on GPT-4 yet for us to talk about. Now, what is large language?
But there is not much technical details on GPT-4 yet for us to talk about. The default LLM for ChatGPT is GPT 3.5. This video is made in 2 years ago, April 2023. So now, 2026 and January. So this video is maybe 3 years ago. Oh, it's old, too old. Mm, regarding LLM, regarding AI, 1 year is very long time. So yesterday's knowledge is old, even old, even yesterday. So 3 years ago, 3 years before knowledge is very old. And how do I say 知識が、腐ってる。知識がもう is not helpful. Okay? By the way, next.
Language model.
Language model. What is a what is a large language model?
Now, a large
A
language
large
model
language
is a
model
type
is
of
a
neural
type of
network
neural
based model
network-based
that
model
is trained
that
on
is trained
massive amounts of text data to understand and generate human languages.
understand.
Now, the model
Huh? Very quick.
of text data to understand and generate human languages.
To understand and generate human languages. A large language model is a type of neural network-based model that is trained on massive amounts of text data to understand and generate human languages. To understand and generate human languages. That is trained on massive amounts of text data to understand and generate human languages.
Now, the model uses the
That is
training
trained
data
data
to learn the
from the
statistical
statistical
patterns
patterns,
and relationships
relationships,
between words in the
towards
language
language. That's me. The model uses the trained data to run the statistical patterns and relationships between words in the language. Hmm.
and then
And then
utilizes this knowledge
and then utilizes this knowledge
to
to
predict the
predict
subsequent words.
subsequent words. To predict the subsequent words. And then utilizes this knowledge to predict the subsequent words. Later, I wanna look up about utilizes and subsequence. Next.
One word at a time.
One word at a time. One word at a time. Maybe the model uses the training data to run the statistical patterns and relationships between words in the language, and then utilizes this knowledge. Utilize maybe use. Maybe use. This mean utilizes and use is near meaning. Use this knowledge to predict is expect the subsequent words. The subsequent words. Mm, To predict the subsequent words. Maybe next words. Mm, my if you can say my, maybe afterwards is mm, my mother, my father, my pen, my dog, my. This is subsequent words. Maybe next, one word at a time.
Now, an LLM is often characterized
Often
by its
characterized
size
by
and
its
the
size
number of
and
parameters
number
it
of parameters it
contains.
contains. An LLM is often characterized. An LLM is often characterized by its size. Characterize. Characterized by its size. And the number of parameters it contains. Maybe characterized is LLM is often characterized by A and B. This means mm, his human character. Mm, mm, the one my character I was characterized by my house environment and where to live, and mm, my friends, and etc. Characterized means mm, my type of thought and the type of feeling, type of attitude, maybe like this, something like this. Next.
The largest
The
model of
largest model
GPT
of GPT
3.5 has
3.5 has
175
175
billion
billion
parameters
parameters
spread
spread
across
across
96
96
layers in a
layers
neural
in neural
network,
network.
making it
Too big too much parameters and spread across 96 layers, too much layers in the neural network. I don't know neural network, but like a brain inside of the brain.
one of the largest deep learning model layers in a neural
Neural
network,
network.
making it
Making
one
it
of the
one of
largest
the
deep
largest
learning models
learning
ever
models
created.
ever created, making it one of the largest deep learning models ever created. Hmm? Largest model of GPT-5 and 3.5 has 175 billion parameters spread across 96 layers in the neural network, making it one of the largest deep learning models ever created. Making it one of the largest deep learning models ever created. Mm.
The input and
Input
output to
and
the
output
model
of the
are
model are
organized by
organized by a
token.
token.
Now, tokens are
Tokens are
numerical
numerical
representations of words.
words. Tokens are numerical representations of words. Numeral numeral is a num, maybe integer, I think. Representations of words. Tokens are numerical representations of words.
Or more accurately,
Or more accurately,
parts of the
parts of
words.
the words.
Numbers are
Numbers
used
are
for
used for
tokens rather
tokens
than
rather
words
than words
because they
because they
can be
can be
processed more
processed
efficiently.
more efficiently. Numbers are used for tokens. Numbers are used for tokens. Numbers are used for tokens rather than rather than numbers are used for tokens rather than words because they can be processed more efficiently. Mm. Mm. Numbers are used for tokens rather than words because they can be processed by computer more efficiently, by LLM more efficiently. Yeah. Okay, let's check the meaning. And so far, uh, already 24 minutes I taking. Uh, okay, let's quickly check check the meaning. Mm. Hey, ChatGPT, could you explain this sentence meaning? So, for example, uh, the model uses the training data to run the statistical patterns and relationships between words in the language, and then utilizes this knowledge to predict the subsequent word, or one word at a time. What mean utilizes and the subsequent in this sentence?
Of course, in this sentence, utilizes means to make use of or to employ something. So when the model utilizes this knowledge, it means it's using the information it has learned. Subsequent refers to something that comes after or follows an order. So subsequent words means the words that come next after the current one. In summary, the model uses the knowledge it has learned to predict the next words that follow, one word at a time.
Mm. Comes after or following in order. Comes after or following in order. So comes after or following in order. So, maybe, mm,
Exactly.
yeah.
You've got it.
Ah,
It's basically just about what comes next or what follows in sequence. It's all about the order of things and how one thing leads to another. If you have any other questions or want to dive deeper, just let me know.
no, it's okay. I got it. Subsequent means comes after or following. So, for example, uh, yeah, there are, there was. Mm, mm, regarding there, the subsequent words is or was or are. It's possibly. So in this sentence, subsequent words means the predictable possible words, I think.
Exactly. You've got it. When we talk about subsequent words, you're referring to the words that are likely to come next. And that can be predicted based on the context and patterns. So, yes, it's all about what's likely or possible to follow after the current word. You've definitely got the hang of it.
Okay, next. An LLM is often characterized by its size and the number of parameters it contains. What mean characterizes?
In this context, characterized means to describe or define the qualities or features of something. So when we say that an LLM is characterized by its size and the number of parameters, we mean that these aspects are key features that help define or identify the model. Essentially, it's about what sets it apart or what it's known for.
Feature, describe feature of something. Uh, I got it. Next. Uh, Please explain neural network very simply. I'm very humble. I'm very poor. I'm very not smart. So please explain simply what's mean neural network.
No worries at all. I'm happy to explain simply. A neural network is basically a system inspired by the human brain. It's made up of layers of interconnected nodes, kind of like neurons. These nodes process information, learn patterns, and help the network make predictions or decisions. In short, it's a way for computers to learn from data and improve over time.
System inspired by human brain. A neural network is basically a system inspired by human brain. It's made up of layers of interconnected nodes, kind of like neurons. These nodes process information, run patterns, and helps the network make predictions or decisions. In short, it's a way for computers to learn from data and improve over time. It's a way for computers to learn from data and improve over time. Okay. So when I want to explain explain neural network, uh, I'm gonna use this sentence. In short, it's a way for computers to learn from data.
Absolutely. That's a great way to put it. It's all about making it simple and relatable. And as you practice, you can always refine the explanation to fit your audience. You're definitely on the right track. If you need any more help, just let me know.
It's a way for computers to learn for data. It's neural network. Neural network is system inspired by human brain. Okay. And next, making it one of the largest deep learning models ever created. The largest model of GPT 3.5 has 175 billion parameters spread across 96 layers in the neural network, making it one of the largest deep learning models ever created. What's in this making it? Uh, I'm not sure about this sentence structure and what's been making it. How do you translate? How can you translate this sentence?
Sure. In this context, making it is used to mean that this characteristic or feature results in something. So when we say making it one of the largest deep learning models ever created, it means that the fact that it has 175 billion parameters and 96 layers is what makes it so large. In other words, making it can be understood as causing it to be or resulting in it being. It's essentially a way to link the cause and effect in the sentence. So if we translate it, it would be something like, それによってそれがになる, or その結果それはになる in Japanese. I hope that helps clarify it. If you want any more examples or details, just let me know.
So making it means making it is used by connection words. So as a result, or it can causing it to be, or resulting in it to being. なるほど。そう、だから、前の文を受けて、その結果、making it one of the largest deep learning models ever created。だから、その結果、これまでに作られた最も大きな、ディープラーニングモデルに、深層学習モデルの一つになりましたっていう、making it っていうのは、その結果っていう感じか。じゃあ。
Exactly. You've got it. It's like saying as a result of that or because of that, it leads to the outcome. So in the sentence, it means that the large number of parameters and layers causes the model to become one of the largest deep learning models. You've understood it perfectly. If you have any more questions or need more examples, just let me know.
Okay, next. Tokens are numerical representations of words, or more accurately, parts of the words. Numbers are used for tokens rather than words because they can be processed more efficiently. What's mean numerical representations?
Numerical representations basically means expressing words or parts of words as numbers. Instead of using the raw text, we convert them into numerical values that a model can understand and process. This helps the model work more efficiently and recognize patterns in the data. So in short, it's just turning words into numbers.
Numerical representations basically means expressing words or parts of words as numbers. What mean? Parts of words as numbers. Numerical representation. Instead of using the raw text, we convert them into numerical values that the model can understand and process. This helps the model work more efficiently. Numerical representations means, なんだろう、数字みたいなことか。言葉とか単語とかを、LLM とかコンピューターが理解しやすいように、それぞれを数字に変えていく、リプレイスしていく。で、そのリプレイスした先の数字のことを numerical representations って言ってんのかな。
Exactly, you've got it. It's essentially transforming words into numbers so that the model can process and understand them more effectively. Each word or even parts of words get mapped to a numerical form, and that's what we call numerical representations. It's all about making text data compatible with the model's mathematical processes. Great job understanding that.
で、その後、numbers are used for tokens。トークンに使われるのは、まあ、数字ですよ。rather than words。その生の、そのままの words よりも、むしろトークンが使われて、because they can be processed more efficiently。それらが、まあ、LLM においては効率的に、まあ、プロセス、処理されるからってことだね。
Exactly. You've got it perfectly. Instead of dealing with whole words, the model uses tokens, which are these smaller units of text, and those tokens are represented numerically. This approach makes it much more efficient for the model to handle and process the information. It's all about optimizing that efficiency in how the data is processed. Great job putting it all together.
うん。よし。じゃあ、それぞれの意味を確認したから、もう、一回閉じましょう。37分。37 minutes. Okay, let's end. Pause. Stop